Okay, the convention in math when we're talking about a right triangle is to label all of the angles with capital letters and the side opposite them with lowercase letters that match. You always put C as the right angle, and lowercase c then is going to be the hypotenuse and across from the right angle. The hypotenuse is always the longest side. A and B, if it's not given to you in the drawing, you can label it however you want, but C always goes with the right angle. Then we have pieces of information about right triangles that you learned in geometry and probably remember. The Pythagorean theorem states that the side length squared, the sum of the side length squared equals the square of the hypotenuse. So we're going to be using that formula to find unknown side lengths. And then SOHCAHTOA is a mnemonic to help us figure out the trig functions. Trig functions are all ratios of side lengths. So if we pick an angle theta in the triangle, so it could be angle A, it could be angle B, then sine of theta is the opposite side over the hypotenuse. That's what the SO part of SOHCAHTOA stands for. Sine is opposite over hypotenuse. Cosine is the K part of SOHCAHTOA, and the A and the H stands for adjacent over hypotenuse. The TOA part gives us tangent. Tangent is opposite over adjacent. And then we talked about our reciprocal functions before. So we have cosecant theta is 1 over sine theta. So if I figure out what sine theta is from the SOHCAHTOA, then the reciprocal, I just flip it, right? I switch the numerator and denominator for cosecant. And secant theta goes with cosine, so that's 1 over cosine theta. And cotangent goes with tangent. So if I can use SOHCAHTOA to find sine, cosine, and tangent, then I also know cosecant, secant, and cotangent. Examples. Find the missing side length and the value of the 6 trig functions. In order to find the 6 trig functions, we have to know all the side lengths. If I'm only given 2 of them, I need to find the third. So if I'm given 2 side lengths, to find the third one, we want to use the Pythagorean theorem. So we've got a squared plus b squared equals c squared. Well, the side that we're missing is opposite the right angle, so we're looking to solve for C. A is the side opposite angle A, and B is the side opposite angle B. But it doesn't really matter, right? Because I'm just going to take the square of both of those and add them together. And if I want to solve for C, C is going to be the square root of a squared plus b squared. So a squared would be 36, and b squared would be 64. And 36 plus 64 is 100. What's the square root of 100? It's 10. So my missing side length is 10. Now, my theta is labeled as angle A, so I'm going to go ahead and write on my triangle that this side is adjacent to theta, this side is opposite, and this side is my hypotenuse. So then we're going to find what is sine theta, what is cosine theta, what is tangent theta, and if I know those, then I can do the reciprocal functions. Okay, so from SOHCAHTOA, sine is the so part, it's opposite over hypotenuse. My opposite side length is 6. My hypotenuse is 10. And that fraction can be simplified. We always want to simplify them. So that will simplify to 3 over 5. Cosine theta comes from the ca part of SOHCAHTOA. It's adjacent over hypotenuse. My adjacent side is 8. My hypotenuse is 10. And that fraction will reduce to 4/5. Tangent theta comes from the TOA. Tangent is opposite over adjacent. My opposite side is 6. My adjacent side is 8. And that will reduce to 3/4. Okay, so now I need the reciprocal functions that go with them. Which function goes with sine? Cosecant goes with sine. Which one goes with cosine? And cotangent goes with tangent. So they're the reciprocal functions. The reciprocal means 1 over, and in the case of fractions, if you do 1 over a fraction, you just flip it and multiply. So the reciprocal of 3/5 is 5/3. I just switched the numerator and denominator. Secant then is going to be what? 5 over 4, and what is cotangent going to be? 4 over 3. All right, let's try another one. Okay, for this one, it kind of matters how I label, because the last problem, the hypotenuse was the missing side length, but it's going to depend on how I solve, how I label these things now. So when I look, the missing side length is across from angle A. 41 is my C and 40 is my B. This means I'm going to have to rearrange the Pythagorean theorem to solve. So if the Pythagorean theorem is a squared plus b squared equals c squared, and I want to solve for a, then a squared equals c squared minus b squared, and a equals the square root of c squared minus b squared. Well, these are big numbers. I cannot do these in my head. I'm going to get the square root of 41 squared plus 40 squared. That comes out to be, somebody do it for me. I say it comes up to be 9. Am I right? Oh, I put a plus in there. Sorry, guys. This should be a minus. 41 squared minus 40 squared. Otherwise, it would be a huge number. It's got to be a minus in there. Okay, so we know all the sides now. theta is labeled for us, so let's go ahead and label. This side's going to be opposite of theta. This side will be adjacent to theta, and this side is our hypotenuse. So we're going to do our 6 trig functions. I want to find sine theta, cosine theta, tangent theta, and their reciprocal functions, cosecant theta, secant theta, and cotangent theta. All right, so sine is the so part of SOHCAHTOA. It's opposite over hypotenuse. My opposite is 9. My hypotenuse is 41. Cosine is the ca. So its cosine is adjacent over hypotenuse. My adjacent is 40. My hypotenuse is 41. Can I reduce these fractions? I can't, but if I didn't know for sure, I could always type the fraction into my calculator and use the math function and hit turn it into a fraction and see if it gives me a reduced fraction or not. But these are not going to reduce. These are not simplifiable. Okay, tangent is the TOA, opposite over adjacent. My opposite is 9. My adjacent is 40. Again, that will not simplify. All right, then our reciprocal functions. We just flip all the fractions, right? I get 41 over 9, 41 over 40, and 40 over 9. Okay, there's a couple of special triangles, and if you recognize, these are the angles on our unit circle. These are the numbers we get on our unit circle. However, on our unit circle, the radius is the hypotenuse, and the radius is 1. On these special triangles, they've made a side length equal to 1. I could turn them into the unit circle if I divided every side by the hypotenuse. So for the 45-45 triangle, if I divided every side length by the square root of 2, we'd have a radius of 1 with side lengths of root 2 over 2, root 2 over 2. And for the 30, 60, 90, if I divided every side length by 2, we'd have a radius of 1. So these really are our unit circle triangles. We're going to find some trig functions using these special ones. Okay, now, honestly, if you asked me to find these things, I could find them all off of the unit circle without having to use these special triangles. Okay, so for the first problem, I want to find the cosecant of 45 degrees. What is cosecant? What trig function does it go with? What's its reciprocal function? It goes with sine, right? So cosecant of 45 degrees is 1 over sine of 45 degrees. So sine goes with the so part of SOHCAHTOA. So I go back here. We're on the 45-degree triangle. And sine is, I can pick either angle, by the way. They're both the same, right? So let's say I pick this angle. Then opposite over hypotenuse is going to be 1 over the square root of 2. And we're dividing by a fraction, so what are we going to do? We're going to flip that and multiply, and we get square root of 2. All right, or square root of 2 over 1, which we would just write as square root of 2. Okay, now what about cotangent of pi over 3? Well, those triangles are in degrees. But we've worked with the unit circle enough now, hopefully, to know what pi over 3 is. Pi over 2, this is a right angle, so this is 90 degrees. pi over 6 is here, pi over 3 is here. So is pi over 3 going to be 30 degrees or 60 degrees? 60 is the bigger angle, right? It's this one. Okay, so we're finding 1 over tangent of 60 degrees. So I go back to my triangle, and tangent, so 60 degrees is going to be our angle, is opposite over adjacent, so square root of 3 over 1, which is just square root of 3, so we get 1 over square root of 3. And what do we have to do to 1 over the square root of 3? We've got to rationalize it, right? So what do we get when we rationalize that? We multiply by root 3 over root 3, giving us square root of 3 over 3. Okay, pi over 4, how many degrees is that? That's right here, halfway in between 0 and 90, right? And so that's 45 degrees. But knowing your unit circle, without me looking at those special triangles, can you tell me what tangent of pi over 4 is? Okay, so tangent of pi over 4, we already know that. That goes to 1. So we're going to get 6 times 1 here. Sine of pi over 3, we just saw that pi over 3 is 60 degrees, and that means that pi over 6, which is here, is our 30-degree angle. So sine of 60 degrees, let's go back to the triangle. Here's my 60 degrees. Sine is opposite over hypotenuse, so that's square root of 3 over 2. Then we need secant of pi over 6. And secant goes with cosine. And so we're looking at cosine of 30 degrees. Cosine of 30 degrees. Let me change color here. So we're working off of this angle. Cosine is adjacent over hypotenuse. So we get this right here to be 1 over square root of 3 over 2, right? So we're going to flip that and multiply. We're going to do the reciprocal. So this whole thing becomes 6 plus square root of 3 over 2 times 1 over cosine 30, we're saying is 1 over square root of 3 over 2. If I flip that and multiply, I get 2 over the square root of 3. Well, if I multiply those together, that's just 1, right? So the answer is 7. Okay, cofunctions pair up our trig functions. They're not the same pairings as the reciprocal functions, though. But they are what they sound like. Cosine is the cofunction of sine. Cotangent is the cofunction of tangent. And cosecant is the cofunction of secant. There's a relationship between them. So I have drawn a right triangle here. And if I pick my angle theta to be where it is, I need to figure out what this other angle is in terms of the information I have about this triangle. What is the sum of all the angles in a triangle? Anybody remember?
180.
It's 180. Okay? Now, That angle is 90 degrees. So that means 180 minus 90, I have 90 degrees left for the other two angles. So if I'm going to label this angle here as theta, then this other angle has to be 90 degrees minus theta. That makes sense, right? Okay, so I've labeled the side lengths. What is sine of theta given these side lengths? Sine is opposite over hypotenuse, so the opposite side length is A, C is the hypotenuse. Now sine's cofunction is cosine. I want to do cosine of 90 degrees minus theta, so the other angle. Cosine is adjacent over hypotenuse. Its adjacent side is A, the hypotenuse is C. So there's a relationship between the cofunctions here. And I have written them all down for you. All right, find a cofunction with the same value as the given expression. Okay, so what we do here is, in this case of sine of 72 degrees, theta would be my given angle of 72. Then 90 minus 72 is 18 degrees. So using this relationship right here, 90 minus theta is my 18 degrees. Cosine's the cofunction that goes with sine. So we would say sine of 72 degrees is equal to cosine of 18 degrees. Now my second problem here is given to me in radians. For all of these, I can replace 90 degrees with pi over 2 if I want to work in radians instead of degrees. Now I was given cosecant, so this is going to be the cofunction we're going to use. So our answer is going to be a secant, and we need to figure out what the angle is. So my theta is pi over 3. My new angle is going to be pi over 2 minus pi over 3. And if I find a common denominator there, that's going to give me 3 pi over 6 minus 2 pi over 6 is pi over 6. Or, you don't want to do fractions by hand. Nobody likes to do fractions by hand. You type into your calculator 1/2 minus 1/3, hit the math fraction button. It's going to give you back 1/6, and you put the pi back on it. So we said secant goes with cosecant. So cosecant of pi over 3 is the same thing as secant of pi over 6. Okay, going back to our trig functions here. The first couple examples we did, we found all 6 trig functions given enough information off of the triangle. Now, we're going to have different pieces of information, and we're going to be asked to solve for a side length. Notice, when I look at this triangle, I do not have enough information to find the side length using the Pythagorean theorem. I have an angle and one side length. Okay, and they want me to find the side length A. I'm given this angle of 61 degrees. So A is opposite that angle. My other given piece of information is 10 here, and that's the side adjacent to my given angle. So which of the trig functions relates the opposite and adjacent sides to each other? Think SOHCAHTOA. Which one has opposite and adjacent together? Tangent does. It comes from the TOA part, right? So what we can say is tangent of 61 degrees equals the missing side length over 10. If I want to solve for A, I'm going to multiply both sides by 10. I get A equals 10 times tangent of 61 degrees. Now we're going to solve this using a calculator, and we're going to round to the nearest whole number. Okay, to do this, and I want you all to pick up your calculators right now and try it. Make sure you get the right answer. You have to be in degree mode. That's going to be one of the trickiest things in this course all semester, is making sure you're in the right mode when you use your calculator. The way you do that is if you hit the mode button, like the third line down is either radian or degree. For degree problems, you need to be in degrees. For radian problems, you need to be in radians. This only matters if you're using the sine, cosine, and tangent buttons on your calculator. Okay, it doesn't matter if I'm trying to add pi over 2 to pi over 3. I can add that. That's not a big deal. But if I'm using a trig function, I have to make sure I'm in the right mode. So when I put this in my calculator and I round to the nearest whole number, I get 18. How many of you got 18? All right, if you didn't get 18, you were probably in the wrong mode. Let's do another one. Okay, in this case, I'm trying to find, I'm given the angle 34 degrees. I'm trying to find A, which is the opposite side, and I'm given the hypotenuse. So which trig function relates the opposite side and the hypotenuse? Sine does. So we're going to set this up as sine of 34 degrees equals A over 13. We multiply both sides by 13. And we need to evaluate 13 times sine of 34 degrees in the calculator and round to the nearest whole number. And you should get 7. Okay, for this triangle, we're trying to find side length B. My angle is 44. B is adjacent to that. The other given side length is the opposite side. So which trig functions should I use to relate opposite and adjacent sides? Tangent. So we're going to say tangent of 44 degrees is 23 over B. Now this one's not so easy to solve for the algebra. All the other ones, we just took the denominator, multiplied both sides, and we were good, right? B, my variable that I care about, is in the denominator. I got to get it out of the denominator to solve for it. So there's a little bit of extra algebra in solving this one. I'm going to multiply both sides by B. When I do that, I get b times tangent of 44 degrees equals 23. And now to get b by itself, I'll divide both sides by tangent of 44 degrees. So b is equal to 23 over tangent of 44 degrees, and rounded to the nearest whole number, I get 24.